Test. Okay. Are we good now? No feedback? Okay. 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 Thanks everybody for coming. My name is Nightlord, and I'm going to be talking about grid computing with the Alchemi framework, which is built on the Microsoft.NET framework. Basically, probably the biggest question is here's a summary. What is grid computing? Grid computing is a form of distributed computing. If you're not familiar with the term of distributed computing, it means running threads on multiple processors on multiple systems. A few different modes is clustering, like supercomputers that universities have or whatever. That's a form of distributed computing. And then grid computing is the same theory, but instead of being in one location, they're scattered geographically. You know, they can be anywhere. It's connected over the internet as opposed to on a single network. .NET is the development platform in Microsoft Windows. They're up to the third version. XP and below runs 2.0, and then Vista, the new Vista, runs 3.0. And it's basically a collection of libraries and components that allow you to utilize the Microsoft built-in technologies that run natively on the operating system in your application, and it allows you to create programs a lot faster because the components are already coded for you. And then Alchemi is a framework built on .NET, on the communication libraries in .NET that allow you to utilize a grid infrastructure and utilize the object-oriented inheritability that you get from .NET and being able to piece together programs using functions that are already written for you. Okay, so grid computing is a computing model that uses multiple processors in separate geographical locations. So if I have an application that utilizes this grid, I can have a grid node at my house in Ohio. Somebody can have a grid node at their house in California, anywhere, and they all simultaneously act as one large computer. So you're unlimited as far as the amount of nodes that you can have or the amount of processors that you can have available to your application. It communicates with TCP/IP, and that's a little different than what a cluster does. Clusters use another protocol on top of TCP/IP to communicate with itself. The computers don't have to be similar. A lot of times with clusters, they have to be like the same type of hardware or running the same operating system or whatever. But with grids, it doesn't matter because it's only using the processor. It's not using the system itself. So as long as you have a handler that's handling the threads, it doesn't matter what version of OS you're running, what processor you have on it, none of that stuff. And it allows programmers to write more scalable applications. You can, if you are using an application that requires like a web app or something like that that a lot of people are hitting on, but you want to keep the response time good, you can use a grid infrastructure to basically outsource those packets or those threads and requests to the different nodes, and you can scale your application based on the amount of users that you have. So when you only have 10 users, your application is going to run just as fast as it does if it has 100 users because you have this vast grid of computers available for you. You can share nodes with other grids in most grid computing platforms. So I can have a grid, and then another guy can have a grid, and we can share our grids together. They could be separately, I could be running Alchemi, and then somebody could be running Globus, and then, but our two grid nodes, or the nodes between our grids can communicate with our own individual grid. And that may not make sense right now, but when I get into talking about the pieces of the grid and how it all works, it'll make a little bit more sense. You can utilize multiple processors as well as clusters in a grid. So if you have a supercomputer that has 500 and some processors, you can hook that up as an individual node within your grid, and then instead of it getting one thread, it gets one thread per processor. So it's getting 500 threads at a time when it's doing its request for threads. And also with individual PCs that have, or like servers that have 2, 4, 6, 8 processors, it also acts the same way. One thing that isn't built into any grid platform currently, but I'm sure that they're going to work on it because dual core is kind of a newer technology. They haven't really gotten to the point where they can utilize that functionality and the low latency. So a dual core processor still is recognized as one single processor within your node. And recently, within the last 2 or 3 years, a new version of MPI, MPICH G2, was written in conjunction with 3 different universities that are on the MPI development team. And they created this version of MPI to be able to run over the grid. Now, the difference between MPI, and if you're not familiar with MPI, MPI stands for Message Passing Interface, and it allows a thread to communicate with another thread. So if you have a thread that you know this, because you can like submit multiple threads in different like routines. If you know that this thread has to complete before this one does, you can tell this thread to go ahead and tell the other thread, okay, I'm done, you can go ahead and go. So the difference between MPI on a grid and MPI on a cluster is the communication. Because you're only using TCP/IP with the grid, it's a different type of communication for MPI. It's a little less reliable. You can lose packets all over the place on the internet. Usually when you're within your LAN, you have a lot more control over packet loss. So it doesn't rely so much on error checking and things like that. It knows when it gets the message that it's getting the full message. And with a grid, it's a little different. So they had to create a new version and able to make it so you know when you're getting the message, you're getting the full message, and it's not going to bomb out that thread or cause some kind of error. Here's some examples of what is currently being done with some grid computing platforms. These are Globus platforms, and Globus is like the granddaddy of all grid computing. I'll talk about that in a little bit. But these are the grid computing is more used in the scientific community or the academic community. These top 2, the one on the top left and the one in the middle, these are both earthquake simulations. They're done by UCLA and their extensive grid network, and to simulate earthquakes and the impact that it's going to have on a surrounding area. The one on the left shows shock waves, and then the one in the middle shows tectonic plate shifting, and then the tension, which are those big arcs of blue and red. It shows the tension going one way or the other. The one on the far right, that is a simulation of 2 black holes colliding and the gravity and things like that. The one on the bottom left is a blood flow through an artery. It's a simulation of that. So they can make a simulation of if you have a clot or a buildup of cholesterol, they can actually see, how your blood is going to react and things like that based on whatever parameters they put in. And then the one on the bottom right is actually protein folding within a carbon nanotube. And that's kind of a newer project that they're working on. So here's some of the examples of what's currently being done in the research community. Limitations with grids. The usability of a grid or a cluster or any distributed computing platform is based on the ability to parallelize your code. What parallelizing means is no data dependency within that block of code. So you can consistently repeat that block of code, and it doesn't matter when it finishes because nothing relies on it, and it doesn't rely on anything else to complete. With MPI, the boundary between that can get a little bit faded because you can rely on another thread to do something, to get that message passed. But generally, that's the point of distributed computing, is to be able to do a task over and over and over again very quickly. And then the other thing about grid computing, and most management, like grid management applications, I have this built in as a built-in feature. If you're running a shared computer, like my home computer that I use is a node. This laptop that I'm using right now is a node on my grid, but I don't want it to be accepting threads while I'm using it. So it needs to know that you're using it and to stop accepting threads and to not process so it doesn't mess with your performance. Okay, how many people are in here are familiar with .NET? Just a couple, okay. I'll do a brief overview of what .NET is. .NET is Microsoft's development platform. It utilizes a ton of pre-written libraries and components that make up what they call the .NET framework. The entire Windows operating system is built upon the .NET framing, the .NET framework. So a button is already coded for you. So when you need to create a button in your application, that is the same code that the Windows operating system is using, unless you overload it or create a new function. And with .NET 3.0, you can tweak your component or your controls more than you could in the past. Like in 2.0 and before that, a button is a button or a list box is a list box, and that's what you get. Okay, with 3.0, you have a list box, but your list box doesn't have to act the way a list box does. You can change it any way you want, and it still inherits the functionality that a list box is, but you can tweak everything graphically, data binding wise, and things like that. It's like I said in here, it's predefined for GUI objects, data connection objects, data objects themselves, and any other piece of the Microsoft operating system. So every communication aspect, every function is essentially a .NET component, or there's a library for it, or whatever. And like I said earlier, it allows you to write applications very quickly, especially with the capability to be able to create your own components. You can create one thing and know that you're going to use that in a bunch of different places, and .NET gives you the tools to be able to make that its own little library or a DLL file, and then be able to utilize that in any application that you want. And you can do the same type of stuff in Linux, but the thing about .NET is it's included in every version of Windows. So you have a Windows box, you code your application using .NET 2.0, you can run that application on any machine that has .NET 2.0 on it because it's built into the operating system natively. And another thing about .NET is it doesn't compile into binary or a binary code anymore. It compiles down into it's called MSIL, which is Microsoft Intermediate Language, is what that stands for. And its original design was to make .NET be cross-platform or platform independent. Now, of course, Microsoft is not going to really endorse that all that much, but because it's not getting down to the binary level, and the MSIL or the CLR is available for anybody to do anything they want with, like the Mono project, it uses the CLR or the MSIL. When it compiles down, it just uses a different framework. Java is true platform independent. .NET was built on the principles of Java, but enhanced a little bit more. So it's a little less time consuming to code. It's a little bit more compatible. You don't have to worry about the same type of errors. Obviously, you're going to get errors because it's Microsoft stuff. But here's a image of Visual Studio. This is the main IDE for .NET programming. Before the .NET 2.0 release and the 2005 release, you had to purchase Visual Studio. It was a pretty pricey application to develop in, but now they have the Express versions, so you can write Visual Basic, Visual C#, Visual C++, and Visual Web Developer, which is actually C# and Visual Basic, but it only outputs into ASP.NET files, so web apps. But those are free, and those will remain free, and they're just a lighter version of the full Visual Studio, so it's not as intense to run on your computer. On this box, I have two versions. I have the VB version and the C# version, and this is written in C#. So this is the interface and how you get the .NET. Now the dot comes from, you see how like midway down the page it's got MySQL.data, .MySQL client, .MySQL connection. That's where the dot comes from. That's where they got that part of the name. Now the beauty about the .NET part is when you define an object, like down here you see this little drop-down box. Now I defined SB as a string builder, okay? So when I hit SB dot, it gives me this drop-down list of every member and every function that is available to that data object. It tells you, so you don't have to know every piece of the code and every little function that each object can do, because it'll tell you. And then it gives you this little tooltip, and it'll tell you what needs to go there, what's acceptable, and it also shows you overloads. And overloads are different versions of the same function that you can do. Like here is the same thing. Here's the append function, and I'm showing you the first one, the fourth one, and the 10th one out of 19 different overloads you can do for this. And you just click the little arrows up or down, and it tells you the different things and the different values. Like the first one, it takes a Boolean value, so true or false. The second one, it takes a character array. The third one, it takes any object. Okay, so that's a little bit about .NET. Now, Alchemi is an open source grid computing platform that is written in the .NET framework. Alchemi uses the .NET components to make it easier for you to interface your application with the grid. Now, like Globus, for instance, which is written in either Python or Java or C, the API isn't as easy to use. There's a lot of data dependent or a lot of library dependencies. So you have to install 8 different modules in order to be able to develop with the full function set in Globus. But with Alchemi, you just have to have the one install, and it gives you the SDK, which has all the libraries. And there's only, I don't know, 8 libraries or something, and those are built on .NET functions. So each library uses a native Windows component to do whatever it is that it does. And it, like I said, it makes it easier to implement strategies because you can code your applications faster, and you know that natively it's going to work the way it's supposed to. You don't have to worry about handling communications or handling data passing or things like that because it does it for you. It contains multiple libraries and applications. There's really only 2 applications that are absolutely necessary to run an Alchemi grid. There's an executor and a manager. And then a third piece is the console, which allows you to manage your grid. Like I said, there's only 2 parts. The manager handles the storage of the threads and the allocation of those threads to the executors, which actually process the threads and passes the information back to the manager, which passes it back to your application. So when you're writing your application and you're coding, your parallel code, you submit all your threads to the manager. You don't have to worry about knowing how many different nodes you have out there, what their names are, what their IP addresses are, whether they're using different usernames and passwords. You don't need to know any of that stuff. All you need to know is your credentials for your application or for your user to the manager, and then you submit threads to the manager, and the manager handles it for you. It handles the passing out to the executors and receiving that information back and passing it back to your application. Okay, the manager you load onto a public PC or server. Ours is loaded onto a server sitting on the internet down in Mississippi. And then the executors are loaded on the individual grid nodes. So this laptop has an executor on it. We have, I think, 7 or 8 nodes right now in our grid, and I'll show you those in a little bit. So one of the main things that people ask is what about my network communications? What do I have to worry about with this? One of the primary concerns is network traffic. Is my traffic going to increase? Well, yes, it's going to increase. But they're little small packets. It's a SYN-ACK transaction most of the time. If it's not accepting processes, it still sends out what it calls a heartbeat, and it pings back to the manager to let the manager know, hey, I'm still here, I'm still connected. And you can set the amount of time that it does the heartbeat. By default, it's set to 5 seconds, but you could set it to anything you want. So every 60 seconds, every 120 seconds or whatever, it can ping back and say, okay, I'm here, and then the manager will send a packet back saying, okay, I know you're here, and then that's it. So the communication, it doesn't overload. It doesn't get in the way of the other packets that are running through your network. The other thing is about authentication. Can you see the authentication credentials going over the network? With the actual executors, each executor has a username and password associated with it, just so the manager knows that it is a valid node to connect to this grid. That stuff is sent over in plain text. I know they're working on doing something with encryption with that, but it's really not that big of a deal. Because even if a user or a hacker or a cracker or whatever you want to say gets that information, they won't be able to do anything with it because all the passwords for administrative privileges are on a database on the manager. And when you try to log on to the manager with these credentials, it's not going to give you the functionality to do anything because it's role-based. Executors only have one function, and that's to execute threads. It cannot do anything else other than execute threads. So the information going across in plain text, it's not that big of a deal. If you log into the console and try to do administrative, that is encrypted. Also, any passwords that are in your application is serialized, so it just comes over as junk. They won't be able to read what it is. It's just the heartbeat pings that the executor sent to the manager require it to send its credentials with it to say that it's a valid node. So what about PC performance? Well, like I said earlier, most of the time, it'll check, grid managers will check and make sure that you're not using your PC. Alchemi definitely does that. It will not execute threads if you are using your computer. That's built in to the framework. It only does it when your system is idle for more than 2 minutes. And it doesn't have to flip to screensaver in order to run. If your screensaver is set to not hit off until 20 minutes, or you don't even have a screensaver at all, then it'll still, after 2 minutes of idle, it'll start accepting threads. But it'll know as soon as you hit that mouse or hit a button or whatever, it'll stop, it'll finish whatever thread it's currently processing, and then it won't accept anymore. Okay, and then what about harmful threads? What about applications that are doing something to try to compromise the individual executor system? Well, the code is executed in a sandbox, which allows it to not touch your actual system. The thread is processed within this sandbox, and like you can't tell it to go out to see and delete, whatever. It just won't do it because it doesn't allow it to get outside of the sandbox. And you can also turn that off. I don't know why you would want to, but it's in place so you don't have to worry about malicious threads coming through. So here's a couple little pie charts about network traffic increase. The manager increases a lot. The individual traffic for the manager increases a lot because it is getting information from all these different nodes, as opposed to the executors. You only gain about 25% more traffic, which now is really not that big of a deal. I mean, unless you're running 56K, you won't notice it, and if you got 56K, I don't want you on my grid anyway, because I'm not going to be able to get information back from you fast enough. So, I mean, there's a bit of a jump with the manager, but generally the manager, you would want to keep it as a dedicated machine specifically for the task of managing your grid, because you have to associate that information in a database. Here is a packet intercepted, and you can see where that red box is, how it's passing over username, password, executor. That is the actual executor username and password. That's why I just leave them at default, because not only do you know what they are when you see it, but you also know that the role in your grid is set up to where it's only executing threads. So I just left it at default because it doesn't really matter. I mean, if somebody's looking, they're going to be able to get it anyway. But you can see how the thread or how the ping or the heartbeat is set up. Up at the top, you can see that it's doing the heartbeat. It's passing the alchemi.core.imanager library. That's the .NET component that it is using to tell you what a heartbeat is. So that's why your application knows, or your manager knows what that heartbeat is, because it's using from that specific library. And then it's got some other information, the version of the core that you're running, the public license key, which is generated every time you log on to the grid, and some basic other information, and that is for statistics, because the console will allow you to get real-time statistics on your nodes. It'll tell you what architecture, hardware architecture it's running, what processor power it's got, the name, the ID, some other thing. I'll show you those in a little bit too. Okay, so to configure the manager, just install it under the default settings. There's not a whole lot to tweak and to mess with if you're just doing the regular binary and you're not messing with the actual source code of the application. Your options for storing information or storing the data, like the thread data, the executor data, user data, things like that, you have three options. You can use it either stored in memory, you can store it in a MySQL database, or a SQL Server database. The problem with storing it in memory is that if your system ever goes down and comes back up, all your information is lost. So you don't have records of the executors that were running. You won't get those back until the executors reconnect. Your username and passwords all reset back to default. So memory is a good choice if you're just going to do something quick, if you don't want to have your grid up 24/7. If you're just going to write one application, do it real quick, you want to use these nodes that you have available, like from somebody else's grid or from something like that, then you can just do it in memory. But a SQL database is definitely the way to go because you can keep track of your whole history of applications that you had, threads that you had, users, nodes, everything. Our grid is run on MySQL. So you can install that directly on the same box that your manager is because that's where most of the processing comes from as far as your manager. It comes from the I/O of the database. So it doesn't make a whole lot of sense to have a dedicated machine for your manager and a dedicated machine for your SQL server because the manager isn't really doing a whole lot as far as intensity in processing. It's just going to be sending out I/O from the database. So you might as well just keep them on the same system. You have to have, if you use a SQL database, then you have to have that installed prior to installing the manager with everything configured, with your root user configured, with any users that you want configured. If you want to run your grid on a different user in a different database, you have to have all that set up prior to installing the manager. It will not do that for you, so you have to have a little bit of knowledge on how to set that stuff up. But after it's installed, you just run the application. For the first time, it gives you a prompt. It asks you what type of database you're using, and depending on which one you choose, you put in the credentials that are necessary to connect to that database. And then once it's installed, and you just click Run on the manager, and you minimize it, and you just let it go. Okay, to manage the manager, you use the console, like I said earlier. The console is included in the Alchemi SDK. Currently, the 2.0, the .NET 2.0 framework version of the Executor and the manager is out and in production. But the console is still in 1.1. There's a lot in the console, and the development team on Alchemi isn't all that huge. I think they maybe have 4 regular developers. So, and they all have other jobs. So it hasn't been updated yet. They're constantly doing work to the Executor and the manager, but they haven't done anything really with the console because it still works. It still does what you need it to do. There's just a couple little buggy things that would be nice to get changed, and I'll talk about them in a little bit too. But you just download that or download the SDK, which you're going to need anyway in order to develop software for the grid. So, and that's when you open up the root folder of that zip file that you get, you have a bin directory and an examples directory, and your bin directory has all your libraries and everything to write a grid application, and it also has the console precompiled sitting there for you, as well as the source code for that. And then in the examples, it gives you a bunch of different examples of things that, little things like factoring out pi, prime numbers, fractals. There's 6 or 7 different ones. So the first thing you need to do when you manage or when you you install your console or your manager, you can't manage your manager by itself. You can't actually configure anything in your manager from the management console because it's just one little GUI window. So you need the console in order to change things. And obviously, like I said, I left the username and password for the Executor and the users set to the default. The users, the only thing they're able to do is view the statistics of the grid, and if you want to lock that down, you can. I didn't care. I don't care if people go in and want to look at things because they can't do anything. And then the Executors, the only thing that they can do is process threads. So if they had the console and tried to log in with your Executor name, they wouldn't even be able to log in. And then the administrator is the one you need to lock down. You need to change that right away because the default is admin. So obviously you want to change that right away. So here is the first screen. When you open up the console, you just hit up in the top left-hand corner, that little computer icon. You hit that, and then here's your grid connection. So you punch in the IP address, the port, which I left to default of 9,000, and then your credentials, and then you hit OK. And it connects you, okay? So the first tree is your user tree. You're using groups tree, and then underneath that is your users, groups, and permissions. Now you can see I have 5 users set up, the admin, the executor, the user, and then 2 special ones that I used for application testing, because I wanted my application to be able to destroy threads after they were finished. So I gave my user, or that night user, a little bit different authority than a normal user would have, which is usually what somebody would use when they're writing an application. So if you double click on one of them users, this is what you get. You get the properties, and you can change your password from in here, and you can also see what they're members of, what group they're a member of. Like I said, everything is role-based. Okay, so then you jump down into groups, and you can see the different groups: administrators, executors, users. You can create new groups if you would like. Once you double click on that, the administrator one automatically won't show you what other administrators in here, but if you went into users or executors, it'll show you what other members are associated with that role or with that group. And then the next tab is permissions. Like you can see, the admin can execute threads, manage its own app, manage all the apps, and manage users. And then here's your permission. You can none and then those ones, and then when you double click on them, it doesn't really tell you anything. So to configure the executor is really easy. You just install the executor, keep the default settings. You just give it the credentials that are set up by the whatever the administrator of that grid. So basically just your IP address. If you leave everything default, all they'll have to do is enter the IP address of the manager system and hit connect, and you'll be connected. So here's what the executor looks like. Like you see up in the manager node, the host IP and the port. The port's by default. There's the IP address of our management computer. And then the credentials are the default executor. When you're connected, it gives you the ID, so you know what ID your node is. So if you look at the statistics for your application or whatever, or there's an error log on your manager, and something happens with the communication, a thread fails, something like that, you associate it with this ID. It doesn't use your host name or anything like that. And then you can also dedicate the node, so it will only be used with one grid. If you don't dedicate it, other grids can connect to that node. And then down at the bottom, there's some log messages that you see. You see the first couple, I couldn't connect to the manager because the manager computer was shut off. So the next tab is manage execution. These are blanked out because I'm connected, but when you're not connected, you can tell it to go ahead and start application executing, and then, or stop executing. And then in your options, here's where you set your heartbeat interval. Oops, let me go back. Here's where you set your heartbeat interval. Retry on disconnection, so if your computer restarts or the manager restarts, it'll try every 30 seconds for however many times you specify. And then right there is that button to enforce the secure sandbox execution. Like I said, you can turn that off, but I wouldn't suggest it. It says to allow with legacy applications, but I've never even found an application that's legacy called Gjobs. So, okay, like I said, the Alchemi Console is used to manage the actual grid. It allows you to create and deactivate, activate nodes, users, groups, applications, and threads, and you can view the live statistics of your current grid. So any applications that are running, how many threads are running, how many executors you have, the processor power that is available to you, the current power that is being utilized, the current power that is being available, because there's a difference between the amount of processing power you have available and the amount of power you have available at that time. So even though we may have 14 gigahertz of processing power available, if I'm using my PC, obviously that percentage is unavailable, and it'll show you that, so it'll only be whatever, 74%, 98%, depending on whatever the ratio of that computer's processing power has to the total. So here's what it looks like in the console with the executors. This is all the executors that we used to have. We have less than that now. But at the time when I did all these screenshots, we only had one executor, which was the machine I was using to do the PowerPoint. But you can see the ones that are grayed out are inactive. They're currently not on or not connected. And then the orange ones are the ones that are active. And then if you click into one of the nodes, it'll tell you its ID, what port it's connected on. That function doesn't work. There's a bug in that part of the console. And like I said, there's a few of these things in the console that are buggy that they need to fix. The username that's associated with that grid, or with that node, and since all of my nodes use Executor, it gives me Executor as the username. And the last ping time, so how long ago it checked to see if it was connected, because the manager will also check back and see if things are there. And then it'll tell you if it's connected, if it's dedicated, and then if you go into the Advanced tab, it shows you the architecture, so you can see what architecture that system is running on, the operating system, the max CPU, the max storage, because you can also do shared file storage between the nodes. I didn't play with that at all, so I can't give you any information on it, but it's in the documentation. And then the number of CPUs that computer has. So if I had 2, it would say 2, or 4, it would say 4, obviously. And then here's the performance of that individual node. And it shows you this little graph, and it tells you how much was available 40 minutes ago, 20 minutes ago, and current. And then here's applications. So under the applications tree, you see all these applications, and then over in the right panel, those are the threads associated with those applications. Okay, now an application, you need to understand, is not the actual program that is running on or for the grid, okay? An application is created within your program that allows it to utilize the grid. You can have a program that can create multiple applications, because an application is limited by the amount of threads that it can process. So if you're running a massive job, like one of the demo programs is the pi generator, and it does every 10 decimal places is an individual thread, and then every 10 it creates a new application to process the next 10. So it makes it so it doesn't bog down the actual grid by having this one massive application. And the other problem is when you are queuing your threads up in your application, all that information has to be sent to the manager to be queued up before it can be processed. So if you have one application, one grid application that is processing 500 threads, it has to queue all 500 of those threads up before they will start running. Okay, the entire application has to be queued before it will start processing. But if you do it in 10 increments, even though you're reading 500 lines, every 10 lines it's going to go ahead and kick off those 10 lines because that application is finished. So you can give, like all these say no name, you can give each individual grid application a name to be able to keep track of it a little bit more. I didn't mess with that because I didn't see the point, but you can do that. You can also give it more information. So if you click on the application, you can get the properties of the application, the idea of the actual grid application, who created it. So that's the application, my program that actually created that grid application. That's what that is. When it was created, when it was completed, what state it's in. If it's currently running, it'll say running. And then the number of threads that it had on that application. So I was processing 10 threads, so it says 10. And then if you go into the thread properties, you see similar information, the application that it was associated with, the executor that it was associated with, when it was created, completed, what state it's in, and the priority. Now, priority can come into play when you're doing MPI because you know that you need this thread to complete before this other thread completes. So you elevate that thread's priority in the queue, so when the executor comes and gets it, it grabs that one first, as opposed to first in, first out, or first in, first out. And here's the real-time statistics that you can see. Up in the left-hand corner, it shows you the number of executors, number of applications that are running, the number of threads that are running, the max power that's available, the total power usage for whatever recorded amount of time is in your database, the current power available, and that's what I was talking about, how that's different than the max power available. I only was able to get 5% of what I was using because I was using my computer. And then the current power usage, which is what is being used at that exact time. Okay, so programming for Alchemi. The most important thing to understand is how to parallelize code. It does you absolutely no good to use a distributed programming method if you do not know how to parallelize your code in. And like I said, that means no data dependency. The first little chunk is parallelizable. Okay, A equals 1, B equals 2, A plus B equals C. Okay, we don't care anything else because we know what A and B is, and we know our output is C. So you would probably return C every time that thread is completed, okay? Now, the second one is not parallel. A equals B, or A equals 1, B equals 2. If C is greater than B, A plus B equals C. We don't know what C is, okay? If C was in there, then you would be able to parallelize it. But because C is not in that block, you're dependent on knowing what C is in order to complete that chunk. Now, you can do that with MPI, but it becomes more complicated. But even with that, you still have to be able to parallelize everything. So it's procedurally, it doesn't get out of order. And then you start getting this big old mess of crap. Okay, just because it's parallel doesn't mean it has to be small. Just because you're doing a repetitive task, you don't have to have this all-encompassing algorithm that's one line of code that it's running every time. I mean, if you do, that's great because it's going to run fast as shit. But if it's not important at how long it takes or how much power is used per thread, then it doesn't matter what size you are using. Okay, it's also essential to understand threading and multi-threading within an application. It's different. If you're not used to multi-threading in your application, it is really different than doing just a normal, wham bam straight through application or an object or a event-driven application because you're still running on one thread, okay? But you can set priority and run multiple processes at the same time without them interfering with other processes, and that's why you use multiple threads. Like in a normal environment, in a Windows environment, for instance, if you're writing an application and you're doing something on your GUI, okay? Your GUI, that is your thread, okay? So anything you do on your GUI, it's not going to allow the next process to go forward. Or if you're running something in the background, like you're trying to make a SQL Server connection or something like that, your GUI is going to get locked out because it's running on the same thread. And that's where multi-threading comes into play. You can send that SQL connection off to the back in a different thread, give it lower priority, give your GUI priority. That way, if somebody tries to use your GUI, that thread is going to get precedence over the thread that you sent back. Okay? And then it throws another little kink in it with the grid application and the grid thread, and that's what I was talking about, where your actual program can create multiple applications, which can create multiple threads. In Alchemi, they use the terminology G application and G thread, which designates it as a grid application or a grid thread. So here's an actual thread in one of the sample applications, okay? That is the actual thread. If these things are okay, then go ahead and process the result. A times B times A. Okay, so that's your thread. Now right here, this little for loop, that actually creates your thread. So you're creating a multiplier thread, so that's your thread object, and then you're giving it the name thread, and you're telling it it's a new multiplier thread, which back here, you can see the next public function up there. That's the thread prototype. So you're passing it 2 parameters. Okay, so every time it's running through, since it's a for loop and it's passing it it's passing it different integers every time. And then it's queuing it up in this GA, which GA is the G application up at the top. And then you're queuing those threads up. And then once that is done queuing, you subscribe to the events, so the thread finish, the thread fail, and the application finish. So your application knows when something's done or when it failed or when your application is actually totally done. And then you start it, which is that actual thread. And then it does its processing, and then it tells your program when it's done. Okay, now this is another application. This is an actual thread as well. I mean, it's much larger than that other one, but it's still parallel. All this stuff doesn't depend on anything else. What this is doing is it's taking an input of a string, encoding it out into MD5, an MD5 hash, then it's connecting to a SQL server, passing that information along with the plain text string, and then loading up a rainbow table. And then here's the actual application. Now, the for loop is real small, but right here is a while loop. Down here, this is my queuing up. So that just shows, that's just an example of how it doesn't need to be small in order to be parallel. Okay, so one of the big questions is, what about Linux? I've been talking all this stuff about Windows. What about Linux? Alchemi doesn't currently run on Linux, obviously, because it's a Windows application. It can almost be compiled with Mono, almost. The biggest issue is the actual Windows Forms component to be able to compile it over into Mono. It would take a little bit of tweaking in order to get it to work. But you can have Linux applications that use the Globus interface to communicate with an Alchemi grid using what's called a cross-platform manager. See the documentation if you want to know more. Or you can use Globus, which I talked about earlier a little bit. Globus is written in Java and Python, and also it's written in C. But that's where grid computing came from, is from this Globus organization or this Globus project. Seti at Home uses Globus. Folding at Home uses Globus. So any big grid, and you might not even know that those were grid applications, but any one of those that are cross-platform, these big scientific applications, they all use Globus. And it's truly platform independent. You can load it on any system, but it's not, like I said, it's not as easy to use as Alchemi. Alchemi is more built for somebody like you and me that wants to set up a grid to kind of just play. I mean, unless you're into the scientific community, then you should use Globus. So does anybody have any questions?
You brought up rainbow tables. Are you doing distributed rainbow table cracking?
Not cracking per se.
Passionation?
One of the things, well, what the application is doing as a test application, and sadly I went to run it last night to make sure it was working, and it doesn't work anymore. But what it was doing was you gave it a password list or like a dictionary file, like just a list of plain text or words, and then it would take those and read them, and every line was a thread in the grid, and then it would submit those, and it would do that processing where it processed it into MD5 and then it inserted it into this table, and then we had a web query written in PHP that you could go and you can enter your password and you could see its MD5 hash, and that was just really a proof of concept, but we weren't doing anything beyond that because I don't have a whole lot of time. Any other questions?
What would you recommend using it for?
Anything that you need to do over and over and over again. The possibilities are really up to the users to define. I mean, a lot of the stuff I found is scientific kind of crap. This is really one of the only security type things that I was able to think of doing that I could do within a certain amount of time. But you could do like encryption and decryption with the grid. You write an application for decryption. You could submit a block of text out to all these nodes and have each node test for a different algorithm, and then once it finds the right one, it'll pass back to your application and say, hey, this is what you're looking for, this is your key that you're looking for, and then the actual application goes ahead and decrypts it, because most of the processing power taken and like brute forcing an encryption algorithm is discovery and finding out what it is, but you could outsource all that onto these grid nodes and do it that way. And the same with encryption. You could chunk out pieces of your text or your file or whatever and encrypt it, n times faster, n being the number of grids or grid nodes that you have available. So.
Now, you said it runs in a sandbox.
Mm-hmm.
In terms of, okay, maybe on accessing the files on the local system, it doesn't have access internet-wise. Can it, access a web page or send it?
Yeah, it can. But that also is dependent on the libraries. Well, when the database connection that I'm making, because it's loaded as the Alchemi database, it allows that connection, and it's just a normal insert statement. But I don't know if you can connect out to website. I'm pretty sure you probably could, but I'm not sure what you could give it. If you could pass it a cross-site or something like that. I'm not sure. I didn't play with any of that. So.
I was curious, maybe if you could use that to spider or maybe search multiple websites from multiple different computers for data if you're looking for something.
Well, that's essentially what search engines do.
Yeah.
They do it, with clusters as opposed to grids. So, I mean, yeah, I'm sure. Any other questions? No? Okay, so before I let you guys go, I have to tell you about HeyCon. HeyCon is held by the Infonomicon Computer Club, which I am a member of. It is happening this year, November 9th, 10th, and 11th in Mississippi. You can go to heycon.info to find out more information. This is more like the chaos communication camp, or the chaos, whatever they call it, where they camp out. That's what we're doing. We're camping out in the middle of the woods. We're going to have an asterisk PBX running with every tent's going to have its own extension. We're going to have, it's not so much technology hacking, it's like life hacking. Okay, we're going to have demos on how to build explosives, how to do all kinds of cool stuff. Okay, we're going to have a paintball competition. We're going to have a stargazing event, a star party. I don't know if anybody's familiar with that, but like having people bring their telescopes and look up and talk about things like that. We're going to have half-an-hour talks throughout the conference, as well as workshops. And there's going to be medical staff on site. Where it's totally legit. We're not just pulling this out of our asses. We're going to have medical staff. We're going to have, we already have permission from, we're holding it at a national park. The con is totally free. Totally free. It doesn't cost any admission. You just show up. Bring what you can. It's really remote, and there's not running water. There's not electricity, so we're roughing it. So yeah, the con funk will be great. So there is a river, though, so if you really want to take a bath. But we're doing this to kind of get away from relying so much on technology to, when we define ourselves as hackers, we define ourselves as what skills we have as far as technology is going. This is more to get away from relying on technology to identify ourselves as hackers and kind of give everybody an idea that you can be a hacker without being on a computer, without using a phone. I mean, you can hack anything in your life, and that's basically what we're doing. More information will be available as it comes, so go to heycon.info to find out more information. Here's some links to some of the things that I talked about. The info grid, which is our grid, setup is infonomicon.org/grid. Okay, within there is the grid crack application, which I wrote. That version works. The version I have on here doesn't work. But the version out on the website works. So you can download that, and it also has the rainbow table lookup, which is populated with some data. So you can go out there and punch in something and see if we have it on there. The Mono project, or the Alchemi project, with the gridbus.org/alchemy. And then monoproject.com, globus.org, heycon.info, and brought to you today by the Infonomicon Computer Club, and thanks everybody for coming.